All right, we got it going? All right. 9 o'clock, I'm going to go ahead and get started. Good morning, my name is Rand Morimoto with Convergent Computing. This morning's session's on IPv6, and this is a topic that earlier this year I wrote a blog posting. It's a 7-series blog post on IPv6, and it is now the #1 group of postings on IPv6, because what I've been able to do is take the concepts of IPv6 and simplify it. I think one of the challenges I found a year ago was that trying to find any information out on the internet on IPv6, you just type IPv6, you get a lot of theoretical stuff of how IPv6 is, the RFCs and how they built it, and a lot of theory. But when it really gets down to, okay, how do I actually configure it and set it up and set the IP addresses on my systems, and how does it work with SharePoint and Exchange and Active Directory, there's absolutely nothing out on the internet. And even today, there's more people that talk about how they think it should work as opposed to how IPv6 should be configured. And so I wrote the blog post. I put this session together. I've done this a couple of times around the world. And so here's the content that I will net out in very simple terms, how you can actually go through and set up IPv6, how do you get your IPv6 address, and then how it works in the enterprise. My name is Rand Morimoto. I write books on the technologies. I actually have a whole chapter in my Windows 2008 R2 book on IPv6. I'm writing a book on Windows 8 right now, and we're covering IPv6 pretty extensively in that title. There's a couple of references here. One, we're videotaping the session today. We'll post the video and an electronic copy of the slides up on the website, cco.com/online.htm when I get back to the office this afternoon. And then there's a couple of URLs here that I will be referring to. Some white papers that I've written on IPv6 configuration and direct access, and so you can download those. One is a direct access guide on how to be able to set up direct access, which I'll talk about in the second half of the session. And then I also have a demo step-by-step guide that I'll cover. So a lot of the information I've made available so that way you have stuff for you to be able to work with. And typical logistics for my sessions. If you haven't attended my sessions before, I do talk fairly fast. I go through the content. You should all have copies of the slide decks. And as mentioned, we will post the slides up. We'll take a break probably around 10:15, 10:30. We'll end before 11:30. Feel free to ask questions at any point. Things that I cover. IPv6, kind of the why, what happens kind of stuff. I cover this stuff primarily from the basis that as you go back to your businesses, the question becomes, well, why should we move to IPv6? So these are things that you can hopefully answer to, whether it's an executive asking the question or somebody basically saying, what happens if we don't go to IPv6? I just kind of covered those that kind of help you explain it to other people. And then the meat of this thing is getting into addressing, subnet masks, masking, gateways, DNS, things of that type. I'll talk about how you route IPv6 in an IPv4 world. Because even though you set IPv6 on your computer, if you go to a Starbucks, they don't give you an IPv6 address. So how do you have an IPv6 device at a Starbucks or a McDonald's or an airport, IPv6 back at your corporate network, but the whole world is communicating through IPv4? And so it's done through tunneling. And I'll talk about what tunnels work and how you configure them and how those things are set up. And then what I'll talk about in the second half of the session is a product called Direct Access. Windows 7. It provides you the ability to have a VPN-less connection to your corporate network. So today, if you were to take a laptop and you go to a hotel and you want to get access to your corporate network, you would launch a VPN client, whether it's Microsoft VPN or a Cisco VPN client. Double-click, type in your login and password, and you now create a tunnel. What Microsoft created with Windows 7 is this thing called Direct Access. What effectively is that when you have a laptop or some device plugged into your network, simply by taking that device off, going somewhere else, and turning it back on, you'll automatically create this 128-bit tunnel all the way back to your corporate network, giving your employees access to file shares, web URLs, and access to information fully encrypted without ever having to go through and double log, double password. And it's also policy-based, so that way you can identify that while the person can move their computer out, you may choose not to allow them to access HR software or accounting software remotely. They can only access maybe email or documents or things of that type. So I'll talk about that technology. It's the first real application built on IPv6. And so that's why I figured if you're fiddling with this, you'll get a chance to play with it. So a handful of kind of slides of why IPv6. So before I actually get too far here, let me make sure I understand you're familiar with IPv6. Anybody here has actually worked fairly extensively with IPv6? Have pretty good familiarity with it? All right, how about IPv4? Let me throw you into 3 different categories. You're kind of an expert at IPv4. You use it on a regular basis. You're familiar. Second one would be you're familiar with IPv4. You set up addresses on servers and workstations and stuff, and you have pretty good familiarity. Or the third one is that you really don't work with IPv4. So when I talk about things like subnets, subnet masks and stuff, that's not real familiar to you. So who's a kind of an IPv4 expert? Use this stuff. Who's somebody who works with IPv4 regularly, have pretty good familiarity? Anybody here hasn't worked with IP at all? So if I use the concepts of DNS, DHCP, subnet mask, I'm not going to lose anybody? Okay, good. If I do actually zip through stuff, and with that, I'm not going to go through the real basics of what an IP address is, but if I do actually go faster than you want, just feel free to slow me down. So the fact that every device on the internet needs an IP address, the current numbering system, which we use today, the IPv4, the last 5 blocks of 16 million addresses each was issued by ARIN, the organization that issues IP addresses, earlier this year. And so as soon as they issued the last 5 blocks, 80 million IP addresses, a lot of blog postings went up saying, oh my goodness, the world's going to come to an end. We're now out of IPv4 addresses. That means that, later this year, you're not going to be able to get an IP address. You're going to have to go to IPv6. Obviously, we're now at the end of the year. We're not out of IPv4 addresses. We're far from being out of IPv4 addresses. But the fact is that with the last block of publicly available IP addresses being issued, the clock is now ticking. At some point, we're going to run out of IPv4 addresses. IPv6 is the next step, and that's once we run out of these, we got to go to IPv6. And it's been a standard for the last dozen years. There's 340 times 2 to the 128th, or 340 undecillion addresses. It's a lot of addresses that are out there. It's not a matter of will we be forced to go to IPv6, it's a matter of really when. It's not going to happen in the next 2-3 months, but it will happen in the next 3 to 5 years. And usually what I tell people is unless you plan to retire in the next 2 years, you will have to do IPv6 sometime in your future. So it's a good time to figure out what it means and how it works. 16 million addresses, 5 blocks issued, a world of 7 billion people. Where does it actually end up in addressing for the amount of time? And it's really every device that's out there needs to be able to have an address. One of the things that saves us is in the way of going through and addressing is we use network address translation. The concept of you put one public address out on your router and then you use private addresses internally. The same concept in IPv6 applies. Instead of calling it a private address, they call it a ULA. I'll talk about that a little bit later. But the concept, and this is the difference between and the practice of IPv6, and that's the thing I'm going to cover with you today, is that the practice of IPv6 is I can put an IPv4 or an IPv6 address out on the internet, and then I can do, with IPv4, I can do public addressing or private addressing, or in IPv6, I could do the same thing, called unique addressing, or ULAs. So out of the 80 million addresses, all of the different public addresses need to be able to have a network. At some point, we're going to run out of IP addresses. So the question is, what happens if an org chooses not to go to IPv6? I've had executives basically say, what if we don't go to IPv6? What it means? Short term, nothing. As I mentioned, there's going to be IPv6, v4 addresses for quite some time. Even 10 years from now, even if the world's completely IPv6, the support for IPv4 is still going to be there. So we're not going to find IPv4 going away today or in the next several years. But when IPv4 does run out, and more than likely they're going to run out in China and India. When you have countries that have 1 billion people, and you have websites popping up, small businesses, people with mobile phones. It's like today, fewer than 3% of people in China and India have mobile phones. You get it up to 30%, and you will run out of IP addresses just having mobile phones that are out there for access. And so at some point in time, there are only going to be IPv6 addresses. The worst case scenarios start becoming your CEO, VP of sales travels to Asia. They go to a Wi-Fi hotspot. They plug in their laptop, and that Wi-Fi hotspot only supports IPv6 because that particular town only has IPv6 addresses. What will mean is that executive won't be able to connect to the internet. And if you didn't configure the laptop, or what most organizations typically do, they don't understand IPv6. They turn off IPv6 on all their servers, and they turn off IPv6 on all the workstations. And that's even worse than not setting up IPv6, because if you actually leave a computer alone and like Windows 7 or Windows 2008, it will get an IPv6 if there's an IPv6 that issues at an address. But what happens is because IPv6 is enabled by default, a lot of times it creates problems with Exchange and SharePoint and some other applications. And so the first thing that when you read a TechNet article is disable IPv6, it solves the problem, and people do that because it's very simple. I can go to my Exchange server, I can disable IPv6, I can go to my Windows 7 workstation, I disable IPv6. That means your device is only an IPv4 device. That CEO now goes to Asia, plugs it in, they only support IPv6. If you set up IPv6 right, the executive would have gotten an IPv6 address and would have worked. But the fact that you turned it off means that that executive won't be able to run it. And so again, putting your head in the sand and saying, let me disable it versus doing it right, it's very simple to do it right, and that's what I plan to cover today. Or the other factor is that if you don't do IPv6 and all of your www sites, your company brings up a website, you're selling something on the internet, but you only address your servers, your customer-facing servers with IPv4, people won't be able to hit your servers with IPv6. And so if all of a sudden in Asia, India, Southeast Asia, Latin America, those sites, those consumers, customers come up with IPv6, they won't be able to hit your servers because an IPv6 client can hit an IPv6 server. An IPv4 client can hit an IPv4 server, but there's no crossover. So you can't be an IPv4 client and access an IPv6 server or vice versa. And so if you have all these users coming up in IPv6 and your server is only set up for IPv4, they will not see you. And so that's why, again, take the extra 2 seconds, put a valid IPv6 address on all your public-facing servers, and then it will hit you with IPv4 or IPv6. And again, it takes 2 seconds to go through and set up an IPv6 address, and I'll show you how to be able to do that and the right way to do it. Benefits of IPv6. So the concept of IPv6, and again, this goes to the theory versus the practice. The theory of IPv6 is that every device that you have automatically gets a IPv6 address. So when you have a mobile device, a mobile phone, a laptop, it will come up with an IPv6 address. It's a fully routable IPv6 address that that device will be able to communicate on the internet. The good thing about the whole concept of IPv6 is that that means that that IP address that just got assigned to my mobile phone is that I can use Wi-Fi here in an IPv6 world. I can take it out. I can use AT&T over IPv6. I can plug it in and I can dock it and I can get an IPv6. That same address follows my device. So when anybody's looking for my device, I have a IP address that follows me. The reality of it is, what if I tell you that every one of your servers in your corporate environment, your file servers, your HR servers, your accounting servers, are now going to be publicly addressed servers? I mean, I think most people in the security world will shudder to think that, well, wait a second, that's what we did 20 years ago, is we put every server out on the internet, and we didn't have firewalls, and everything was fully routable. As much as it's good to be able to have a fully routable device, from a security standpoint, it ain't never going to happen. Right? Nobody's ever going to go through and put their servers out on the internet with a public address. And that's why the practice of IPv6 is people still put their servers behind a firewall, and they give it addresses, and then they block so that people can't get access to those servers publicly. And that's just like network address translation today, is that you have your internal servers that don't communicate outside. That's for servers. But how about a mobile phone? Do you necessarily care that your mobile phone has a public address? And that's the difference, is that IPv6 makes perfect sense for mobile phones. And there's going to be more mobile phones, or there are actually today more mobile phones, it happened last year, that there are more mobile phones and tablets than there are computers. And so when you bring up a mobile phone, who cares whether that mobile phone is plugged into AT&T or Wi-Fi with the same address? Because mobile phones, by virtue, are mobile. And people are going through it, and you should have some level of security on the phone so somebody can't hack your phone remotely. And so that's where, when you read on the internet about IPv6, think about everything around the theory of IPv6 really applies to mobile phones, but the practice of corporate IT is going to still apply to how you do firewalls, private addressing, and secured networks. And so you're going to have two ways at IPv6. Benefits of IPv6, handful of different things. So the first thing is source address selection, which is effectively a IPv6 gives you, it automatically will issue an IPv6 address to every device. It means that you don't have to statically address a device. You don't have to go through and do DHCP to a device. The device, by virtue of turning the device on, will automatically go out to the network, identify what the network segment is, and get an IP or get an address, an IPv6 address. So it automatically does source address selection. For mobility, the concept, as I mentioned, is that the device can switch carriers, Wi-Fi, mobile, WWAN, whatever it is, keep the same address in mobile and route, so you never have to go through and switch your address. By default, IPv6, everything is encrypted. It uses IPsec, default enabled, meaning 128-bit encryption, encrypted on every transport of IPv6. Good part about it is that with this device that happens to be floating around, is that the transport is encrypted. The bad part about it is for any of you who are using sniffers to be able to identify traffic, you're no longer going to be able to identify the traffic the same way you do with IPv4. And so that concerns a lot of IT people from the basis of, well, if I can't sniff the traffic, what do I do? The key to it is you have to start doing device-level security, not transport-level security. You have to know what device you have. You have to manage the data on that device or the server. You have to protect your database. But the transport itself, you're not going to be able to control because all traffic in IPv6 by nature is going to be encrypted, good and bad. Quality of service is just like the source addressing. It automatically gets an address, and it automatically identifies the best route to go source to destination. It automatically will go through and identify the bandwidth needed. And so IPv6 as a transport will automatically tell a router or tell a system that it needs more bandwidth because it's transmitting video or audio. And so it has the ability of going through and doing quality of service automatically and prioritize stuff. And then this whole stateless addressing, I'll talk about this, but what you'll find in IPv6 is that you don't define gateway addresses. Today with IPv4, I give it an IP address, I tell it the DNS name server, and then I tell it the gateway or the route to the internet. And the way that IPv6 works is you only give it the first two things. You give it an IP address, and you give it a DNS name resolution. But the actual gateway is what they call stateless address configuration, is that it will go through and communicate with the routers and devices on the network to figure out its best flow to get out to the internet. And so you may have 2 or 3 routes out to the internet. It will know the nearest route by going through and doing stateless addressing. And again, I'll talk about more of this as I get into the specifics. Importance of knowing about IPv6 is a foundational skill. We're going to have to deal with it at some point in time. Most orgs are already dealing with IPv6 today. If you've ever set up Exchange 2010, SharePoint 2010, Link 2010, Windows 7, you're dealing with IPv6. It is enabled by default. It is the #1 reason that people have problems initially setting up Exchange and SharePoint, because as much as you set up Exchange or SharePoint, is that it actually uses IPv6 as the default routing communication protocol. And that's why you'll find most TechNet notes will basically say, turn off IPv6, that way everything goes back to IPv4. And then all of a sudden Exchange and SharePoint and everything works. But what you're effectively doing is you're kicking the can down the road by not configuring it right in the first place. If you configure it right, then you don't have to disable it. It actually just works. And again, I'll talk about where that fits in. So I always say get ahead of the curve. The question I get a lot of times is that isn't IP addressing something that your LAN, WAN, networking infrastructure people do, not something network Windows administrators do? And it's true, your WAN people are directly involved in IPv4, IPv6ing. But when we go through this, we typically look at it as you typically don't ask your LAN, WAN person to help you set an IP address on a server. You don't say, hey, can you come over here and set my IP address, because I don't know how to type. And so you have to know what to ask, right? You have to know the IP address, you have to ask them for the DNS address, you have to ask them for the subnets and some of that type. And so while the addressing scheme may be created by your LAN, WAN people, configuring it on a server or workstation is something that the Windows person is going to do. When you set up Active Directory, DNS servers, DHCP servers, do you ask the LAN, WAN person to come in and help you set it up? No. You basically ask them for, again, what is my DNS, what are my ranges for DHCP, what should I do in configurations, and you set yourself. Do you want your Cisco guy touching your Exchange, SharePoint, AD, SQL? No, they don't want to touch it either, right? I mean, it goes back to, you have to understand where that fits in. So the person who's responsible for doing any of the IPv6 addressing is the person who understands it. Again, the purpose I'm covering this stuff is that you have a familiarity with it. At a minimum, you want to say on how addressing has worked. If you don't want to get an IPv6 theorist who's going to basically say that, yes, IPv6 is globally universal. We're going to go through and set it up so that every IP address on every server is publicly available, and we're going to open up everything to the internet. And I've had purists come to my conferences and basically say, get rid of your firewalls, open everything up, and make the world, one big happy family. And that sounds great. I said, have you ever set up a network before? And they're like, no. And typically the people who are the purists who will post things on my blog saying that you're breaking standards is I always go back and say, hey, have you ever actually set up a network and tried to secure it and protect it and manage it? And they never blog post back. But, it's kind of like, yeah, they've never done it before in the real world to understand, there's that theoretical way of doing it, and then there's the way that actually works in the real world. A bit of a tidbit, we're on IPv4 today. We're talking about IPv6. I always get the question, whatever happened to IPv5? So I put this together. The internet first came out using NCP, Network Control Protocol, and IPv4 was put into place in 81. It went live in 83. And IPv6, I mentioned, has been available for the last dozen years. But there's been IPv1, V2, V3. IPv4 was finally the one that stuck and worked. There was a thing called IPv5. It's a stream transport. It was really meant to stream TCP/IP traffic. It's used, it's just not used that frequently. IPv6 became kind of the next standard. There is an IPv7, 8, and 9 that came out as recommendation specs, but they've, for the most part, been deprecated. Nobody's using those standards. So you're kind of stuck with IPv4 and 6. Anybody ever asks you, you have that information. All right. Let me go into IPv4, and because everybody has a good familiarity, I'm going to cover this relatively quickly. But I want to be able to at least set some standards on IPv4, because when we go to IPv6, it is exactly the same. So the concepts of IPv4 today is you get an email, you get an IP address, 192.168.1.100. Today with IPv4, you take your address and you mask, meaning that when I put this 255.255.255.0, I'm basically blocking those first three addresses, and I'm only looking at that very last subnet, or the last block of octet of addresses. And so effectively, in this case here, my network is 192.168.1, and then my device over here is number 100. And that device can be anywhere from 1 to 254. So I'm going to have 254 devices in one network, basic IP addressing. I could put the mask, instead of putting the mask 3 in, I could put the mask 1 in. Oops. And by doing that, now basically I'm saying that my network is 10, and my device is the last 3 octets. In that case there is that I have one network, 10, and I can have 254 times 254 times 254 devices. I got 60 million devices. So that's masking it. It's basically setting up an address and it's blocking it out. There's nothing that prevents me from masking further on, so I can go through and put a mask across the first 2 octets. And in that case there, my network is 1012. My devices is 3.50. And so in that case, I can have 65,000 devices, 64,516 devices. So that's the concepts of IPv4 that you've all worked with in the past. Setting up an address, masking where the network part and the workstation part fits in. IPv6. Instead of using 4 sets of numbers followed by a period, there's actually 8 sets of numbers. 1, 2, 3, 4, 5, 6, 7, 8. Instead of being separated by a dot, it's now separated by a colon. And there is an actual naming scheme that goes on. Is that the first 3 blocks of numbers is the network. The next block is your subnet. And then the last 4 blocks are your devices. And so in that particular case there is my network, in this case here is FD3000000000. That would be something that your internet service provider will provide you. AT&T, Sprint, they'll provide you a network that basically says that that IP address is going to go to the United States, North America, out of San Francisco. Typically there's a table in IPv6, just like IPv4 today, that will tell you that a specific internet provider is going to route your traffic down a certain path to get to you. And so that's going to be the networking piece. The subnet is now up to you to choose which subnet is going to be for your servers, your workstation, building 1, building 2, building 3. You may choose different subnets. You may do subnets in that case there based on cities, based on floor, based on buildings in a campus. So you can choose what subnet you want. And then your device is now, instead of having 64,000 or 16 million devices, you can have 72 million devices in your network in this particular case. You'll find here that I don't have a mask. I'm not going through and saying mask it out. They specifically in IPv6 named the address. So in this case here, I'm not masking to say that this is subnet blank, 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 blank. I'm basically saying this is subnet 1. If I want a different subnet, I can say this is subnet 2, subnet 3, subnet 4. So I can actually just name each subnet by giving it a number. There's nothing to prevent me from making my network all the way down here make this my subnet, make that 0001, 002, 003, and then I can have over here the number of addresses for my workstations. So this convention of network, subnet, and device is the published standard, but there's nothing to prevent you from making your network all the way down here, make this your subnet, or even make it all the way that this is your network and this is your subnet. And you can have up to 16 subnets, or you can have maybe 64 subnets with workstations. Again, you can go through and set the addressing. Now, when you take an IP address of this type, some of the shortcuts that they do in IPv6, and this is why IPv6 is sometimes hard to read, because you should see it in this format if you do it in longhand. But what they do in IPv6 is they start cutting out numbers. And anytime there's a group of numbers that's preceded with zeros, they actually just whack those zeros. So in this case here, instead of having 0001, they just go 1. Instead of 003E, it's 3E. Instead of 0009, it's just 9. And 000E, it just becomes E. So they start whacking off preceding zeros between the colons. The other thing that it does is that when you end up with blocks of zeros, they actually go through and whack out the blocks of zeros and just put a colon, colon. So in this case here, this big long number ends up being FD30 colon colon 1 colon FF4E colon 3E colon 9 colon E. And we just took out all the zeros preceding every one of the numbers, and then you have to put a colon colon. Now the thing with this colon colon thing is a little confusing. The colon can be anywhere in that block. You can only have one set of colon colon. You can't put a colon colon 3 2EE colon colon C, because what happens is that when I put the colon colon here, you know there has to be 8 blocks of numbers. 1, 2, 3, 4, 5, 6, 7, 8. I'm missing 2 blocks of colon colon, so I would put a 0000 colon 0000. I'm going to put 2 sets of zeros. That's what was missing. If I do it here, where I actually put 2 sets of colons, at that point I don't know, do I put 1 here and 3 here? Do I put 2 here and 2 here? Do I put 1 here and 3 here? You don't know. And that's why, from that basis, you can only have one set of colon colon in an IPv6 address. So in that particular case there, this is the most simplified version of that address. When you're actually sitting there and trying to figure out what an IP address is that you have to actually sit there and count how many colons you see. That's 1, 2, 3, 4, 5, 6, and that means that over here is 2 blocks of 4s. And that colon colon could be here, it could be here, it could be here. And if you actually go through and you have a 000000001, you can basically just say colon colon 1. And now you know that there has to actually be 7 sets of zeros here. 0 colon 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 1. Or in the case of if it's all zeros, it's just colon colon. So that's why when you read an IPv6 address, is that you may see it this way, you may see it this way, you probably should see it this way, but it really depends on how the person wrote it. All 3 or 4 ways are correct. And so that's why when people look at it, it's like, how could this be the same because it's missing stuff? Okay? That's a simplified of reading the address. Question that people ask, where do I get an IPv6 address? And the answer is, wherever you got your IPv4 address from. Today, for the most part, when you get an IPv4 address, you call your internet service provider, AT&T, Sprint, British Telecom, Comcast, and they will give you an IPv4 address. In my case, we use AT&T, and they've given us a 12.155.166 address, and that's what we use to publicly address it. You make the same phone call to your internet service provider today, and pretty much the internet provider IPv6 is. You asked them a year ago, you got routed around, and it was like 3 or 4 hours on hold, and you still got to somebody who knew no idea what an IPv6 was. Today, you can call AT&T, call Sprint. They will give you your own block. They will ask you how many addresses that you want. They'll give you way more addresses. They will basically give you upwards of about 60 million IP addresses that you can have. So you just call your phone company. Can I get my own IPv6 address? So how many of you actually own your own IPv4 addresses? So you're lucky to own your own. You're lucky many times if you're a government agency, you've been around for 20 years, you're old as dirt. Your company owns an IP address. IBM owns their own address. There's a lot of companies that have, 20 years ago actually were able to register and get their own IP address. Or you can actually buy them on the open market in many times. You can go out and buy your own IP addresses. Can you get your own IPv6 address? Yes and no. The more standard answer is no. Just like today, theoretically, no, you can't buy your own IPv4 address today. The only way that you theoretically can get an your own static IPv6 address is that you have to be an internet service provider. You actually have to be hosting people, and then here's the URL. This instructions. It's a 7-page document. You fill out this little form. You submit it to Aaron. All you have to do is basically say you are hosting and you're an internet service provider, and you fill out the form, you mail it in. Then they will review it, and it takes about 3 to 6 months, and they will send you back more than likely, they will send you back a letter saying, no, we're not going to issue it. But you just come up with a good case of why you're an internet service provider. So if you're looking to be able to do that, fill out the form, submit it. You might as well try to get your own internet address. But just like today, more than likely your IPv6 address will end up being the IPv6 address that you get from an internet service provider. So what happens if you switch from AT&T to Sprint? Do you give up your IPv6 addresses? Absolutely. It's just like today. If you move from Sprint to AT&T, Sprint's not going to allow you to keep your Sprint IP addresses that they loaned you. You have to go to AT&T and you're going to have to re-IP address all of your external devices. And so it's no difference. You go through and address, every time you change internet providers, you move, you have changes, you have IPv4 things, you have re-IPv6 things. That's why it'll be nice if you can get to keep your own IPv6 addresses. The same thing applies, though, is that if you have workstations then. If you got your own IPv6 address space, do you actually go through and assign all of your workstations a IPv6 address? And the answer today is when you think about even IPv4. If you own your own IPv4, really the only devices that have static addresses are the ones on your edge, not to the public facing. But more than likely internal, all your laptops and workstations are using private addresses. And the same concept applies in IPv6, that even if you got an IPv6 address, all of your workstations, laptops, and stuff internally will continue to be a private address, likely. From a security standpoint and configuration standpoint. So how do you go through and do network addressing, private addressing? NAT is in IPv6 called ULA, Unique Local Addressing. Same concept applies. I'll talk about that a little bit more in detail. Documentation is that there's a number of IPv6 addresses that have been pre-allocated, and the address space that's been pre-allocated, 2001:0DC0, and then everything beyond that, is actually, if you're ever writing a white paper or a document or you're blogging something, is that it's just like it's a private address today that you would use. Anytime you see something with 2001:0DC0, it's a document. It's a white paper. It's not intended to be a public address. It's not intended to be a document for internal use. It's really meant for this is how you document stuff per RFC. So if you go through and search for stuff, you know that that's a very generic block of spaces. All right, let me get into private addressing. So you got static addresses, which I can go through and get from my internet service provider, or I can become my own internet service provider and get my own static addresses, or if I want to be able to set up a firewall and I want to have all my internal addresses internal, you create this thing called a unique local address. And unique local addresses start at FC00::/7, which basically is any address that starts with FD. So any address that you see starting with FD is a unique local address. The thing about a unique local address is just like a private address today in IPv4, it's not routable. Meaning that if you take a 10 dot network or a 192.167 network, 192.168 address, you can't go out to Starbucks with a 192 and get anywhere. It's only going to be internal to your own device. Same thing as if you statically address a device with an FD address, it will be great for internal. It's not routable, which makes it good because the only way that that device will then be hacked is that you have some kind of router that allows outside people in through that router and into this FD address. And again, that's back to that security concept is theorists will basically say this is bad because that means that, wow, that IPv6 server can't be moved. It's like, that's good because I don't want my IPv6 server to move. I don't want it to be taken somewhere and plugged in somewhere. I want to know that I have an FD address that's non-routable, and the only way to get that darn server is I got to put a firewall router in place to route to it. So again, private addressing or unique local addressing gives me the ability to go through and set it up. How do you go through and get one of these little FD addresses? Start with FD and pick anything else after that, and you're good. So you can actually set it up so it's FD 00000000000001. And then you can give it a 00000001 as your workstation, and 2, and 3, and 4. You can make up whatever you want. There's a really nice random number generator. The simple DNS makes this private address DNS generator. which is kind of cool. You just basically go through, you run simple DNS, private, it goes through and it just gives you an FD address, ADEA06 FD6C. There's my subnet that they've given me, and everything after that becomes my workstations. It's just a random number generator. It just came up with something. There is a chance that a 2 in 128th chance, or 1 in 328 trillion chance, that they will randomly generate a number that's going to be same as yours or somebody else's. So a 320 trillion chance, meaning that you can get struck by lightning at least 50 times on your way home from work before you're ever going to come up with an address that's going to be locked in that somebody else is going to share. But it's a good way of actually just coming up with a random number. I went through and did a random number generation off of my system, and I pulled off this address. And so I'm going to go through and just show you the real basics of configuring an address. So if I go into my server here, and I go into my network adapter, and in my network I have an IPv4 address that I've given, but I haven't given any IPv6 address. So I'm going to go through in properties to IPv6, and I'm going to statically address it with this random number that FDA8 06C3 CE53A90. Okay, and then I'm going to go through and give it a workstation number. So 0000 0000 0200. Okay, and then default gateway. This is where cut and paste works great. Cut, paste, and I can just give it 1. Or I can even cut it down with all those zeros. Remember, I can get rid of all those zeros, so I can actually get rid of that 0, that 0, that 0, that set of zeros. And so there you go. That address here is the exact same thing as that address there. All I've done is I replaced all those sets of 00s with that colon here. I got rid of the 0200 with just 200. And so this address is actually identical to this address. And that is it. My device now has a statically addressed ULA, unique local address, just like if I gave it a 10 dot network or a 192 network address. And so when I go to ipconfig, you'll find here that there's the 192 address, and then FD186C3 CE53 8:1 and :200. So just what it by default when you do ipconfig, it goes through and truncates it. So that's why even if I typed it in with all the zeros, is that now ipconfig will actually take out all the zeros and put the colons in there. Okay, so now my device has a static address. What you'll also notice here is there's a link local IP address, this FE80 1895. This address was actually the dynamic address that it gets. As I mentioned, every device on the internet or every IPv6 device takes its own address, what they call a link local address. And what it is that it goes out and finds an address and gives it a random address. That address is routable. That address actually will allow that device to move out. And so by default, though, since I statically gave it an address, it's going to use that as the primary address. But every device, even if I didn't give it a device, will have a link local. And this is the thing that screws you up in Exchange and SharePoint and stuff, is that every server will automatically have this link local address. And that's why when you turn the computer on and you do Windows 2008 or 2008 R2, your computer is actually talking through this link local IPv6 address. The problem with that link local address is that while your devices, your Exchange servers can communicate with each other, is that you haven't set up gateways, you haven't set up masks, you haven't set up anything. And so your Exchange servers can communicate with each other, but if you're running in an Active Directory 2003 environment, your 2003 servers are running Windows 2003 that don't use IPv6. And so what happens is your Exchange servers talk to each other, but they can't talk to AD. And that's why you get these weird errors. It basically says that, you know, I'm communicating through IPv6, but I can't find, and they typically show up as authentication error, server cannot find domain controller. You're like, what do you mean can't find a domain controller? I can ping it. You're pinging it in an IPv4 world, but your servers are actually communicating by IPv6. And by default, every Windows 2008 server, every Windows 7 workstation first communicates by IPv6 before it fails over to communicate over IPv4. And so that's why when you went from XP to Windows 7, you went from Windows 2003 to 2008, you went from communicating by default IPv4 to IPv6. The quickest way to solve that problem, if you turn IPv6 off, you're now going to communicate only by IPv4. The problem that I have with that is that, okay, at what point in your life are you going to go through and put IPv6? Turn IPv6 on, give it a static address, give it a route, give it a gateway, make sure it all works. Turn off IPv4, make sure your thing communicates with IPv6, because the only time that's ever going to go to IPv4 now is if you ever turn off IPv6. Because again, by definition, all Windows 7, all Windows 2008 servers communicate primarily through IPv6 as the primary communications, unless you turn it off. So, gave it a static address. You could use this little random generator. Let me get a little bit more into some of the IPv4 addressing. So your network, first three groups, subnet becomes the next group. Now your subnet, you can make it whatever you want, 0001, 002, 003. And that's how you address your subnets. And so if you want your servers to be on 0001, you set that up. If your building 2 is in could be 0002, building 3 could be 0003. And so you can statically address it. You have all four of these subnets by practice, all four of these numbers to be able to set up your subnet. But again, there's nothing to prevent me from making it FD3 0000000000000000001 and use over here and make that 0001 00002 003. It's just an address. It's a full, and it's, especially if it starts with an FD. If it starts with FD, it's non-routable. It's internal only. Everything from here forward is really just up to you. And so don't make it complicated on yourself. I've seen organizations where they actually go through and start subnetting over here. Well, that's great. You could now have upwards of 64 to 10 to the 112 address number workstations. You know, I don't even know. It's more than a billion and a trillion and quadrillion. I start running out of what those next numbers are. You got that many workstations. Let me tell you, you're not going to have a trillion workstations. And so, you know, from that basis, simpler the better. Here's where Microsoft differs from others. Microsoft supports a gateway address. IPv6 by definition does not. And so when I go into my IPv6 configuration here, and I specify an IPv6, I specified a gateway here. But what you'll find, and so all my communications will go out of that IP address, and that could be my Cisco router, that could be my TMG or ISIS server or whatever it is. That could be the inside port of my gateway, just like I do an IPv4. And you'll find here is that, I don't actually have an address, but the IPv4 and IPv6 typically are the same device on there. But by theory, the way that IPv6 works is that they don't use this IP gateway, and I'll talk about the whole addressing scheme that they use for routing of information. DNS is DNS. The IP address that I define on my DNS server in IPv6 is the same IP address of my DNS4 server. So in this case here, I specified that my DNS server is actually the same IP address as my IPv4 DNS server. It should be, right? I mean, DNS is DNS. As long as your DNS support server will allow you to address it with both an IPv4 and IPv6 address, your DNS server should be that address. And actually, if we go into DNS, you'll find that in my DNS server, I have my IPv4 address, 192.168.3.200. And there is my IP address for that server in IPv6, both statically addressed. Oops. So DNS picks the thing up, automatically gives me the DNS address. So that way you never have to remember these numbers here. It's very hard in the IPv6 world to remember an address. I bet you can wing off your DNS address, your Win server address, your gateway addresses in IPv4. I challenge you to do it in IPv6 over a long period of time. You go nuts trying to figure it out. So you use DNS a lot, and here it is, just a screenshot. IPv6 address, gateway address, DNS server address. ipconfig shows you all the stuff there. Configuring a DNS server for IPv6, simply go into Windows DNS or whatever your DNS is, give that server an IPv6 address. You can do an ipconfig register DNS, and all of a sudden, that IPv4 DNS server becomes an IPv6 DNS server. And you'll have your address space. What you may find that you'll have to do in Microsoft DNS is that as much as the DNS address shows up in the DNS table, is that the reverse DNS lookup zone actually does not automatically end up in DNS. And so what we typically find is that you'll have to go into Microsoft DNS and actually put in your reverse DNS address. And it's the same address, but backwards, followed by period. So FD8806C3C E53890. And it's the same thing here, but separated by periods backwards. So that's how you put in. And if you don't put that in there, your DNS server will not do a reverse lookup, meaning that if you try to now do IP to name to IP, you'll sometimes get a failure. So just add that in. DHCP. So concept of DHCP, and again, back to the standards versus the practices. There's three ways a device can get an IP address. In today's world, there's two ways you can get an address. You think about it today. You either statically address it or you dynamically address it, right? You basically give it an address and you key it in, or you use DHCP. In IPv6, they give you a third method. So I still can statically address an IPv6 server. I can go through and use DHCP. I'll show you that in a second. Or the third way is that link local, is it'll go through and grab its own random number. Of these three, static is static. The reason why I would statically address it is pretty much every server I want to statically. You don't necessarily want to dynamically address your servers because you want to pick the server, you want to name it, you want to have it the same IP address probably every single time. Nor do you want to let IPv6 go through and randomly come up with a number. It's good for a phone, not good for a server. So you typically find on a server, you would statically address the server. A workstation, however, you may choose to dynamically or let it automatically create its address. Again, if you're an IT person, you are an IT person, would you want it to randomly come up with a number, or would you want to actually statically address it? And typically when I talk to most IT people, they're like, I'd rather dynamically address it, because if I dynamically address it, I can set the subnet. I can go through and know that if I actually look at an IP address and I see it fits in this set of range, that I know that it's in building 1, or this is in building 2, or that this is a server, or this is a laptop. So we find people set your DHCP zones up based on the type of device you have. If you use that third option where it just goes through and randomly pulls a number, you look at it and you have no clue. Is that a workstation? Is that a server? Is it in building 1 and building 2? So we typically find, so that's where we do differ in the managed IT world, that the IPv6 purists will tell you don't use DHCP. And most IT people will say, I'm not going to let the thing just randomly create a number. Let me give it a DHCP address. So let me show you how to go through and set up DHCP. It's very simple to go through and set up DHCP. It works the exact same way in the way of configuring up DHCP in general. I'm going to launch, in this case, Server Manager. Collecting data, thinking. There it is. I'm going to add a role. I'm going to add the DHCP role. It automatically comes up with an IPv4 address for this DHCP server. Automatically knows the AD domain, the DNS server. It pulled it off the DNS, off the network adapter. I'm not using WINS in this case here. I could if I want to. DHCP scope, I'm not going to create an IPv4 DHCP scope at this point, so I'm just going to leave that blank. I'm going to get to the DHCP v6 portion. Here's the two different options. Enable stateless mode for the server, disable DHCP stateless mode. Stateless mode, again, back to this whole concept of stateless mode. You have two options when you set up DHCP and IPv6, is that you can define a gateway or you let it find its own gateway. So the default and the recommended is enable DHCP stateless mode. What that means is that you will, on all your static servers, you will give it an IP address, DNS address, and statically give it a gateway address, because your server, you want to know where that server is going route through. But on a workstation or a laptop, typically you will dynamically give it an IP address, dynamically tell it, go find this particular DNS server, and what you can do is while you can go through and give it a gateway address, if you leave this set for stateless mode, what it'll do is it'll actually go out to the routers now, the DNS server and the routers, and say, where's my nearest gateway? And it'll go out and find the gateway. And so we usually say use this as a default. Say, for example, you specifically on all of your workstations wanted to dynamically give it an IP address and dynamically give DNS, but you specifically want to name the gateway. At that point there, disable the DHCP stateless mode. And what will happen now is on every one of you have to actually go through and send a command to tell it to use this IP address for your gateway. The good part about it is that you now know that all of your workstations will go through a gateway. The bad part about that person now takes their laptop, goes to Starbucks, plugs it in. Starbucks gives them a DHCP address and a DNS server, but because you statically address the gateway, they're going to be sitting at Starbucks trying to get access to that gateway that doesn't exist at Starbucks. And so that's why I don't like doing the non-stateless mode and forcing a workstation. I'd rather have it use more of the standard, so I'm going to give it an IP address, I'm going to give it DNS, and I'm going to let Starbucks, McDonald's, San Francisco International Airport automatically give me a stateless route out to the internet. Okay, so default is enable DHCP, use that as the standard. It's basically going to say what is the DNS server for the system. Again, it went to the IP address of this network card, validated, my DNS works. Who's authorized to set up this DNS server or DHCP server, and I'm going to install it. That's all it takes. And then if you already have created DHCP, you just go through the configuration and you add that stateless function and you enable DHCP v6. DHCP v6 is supported on all Windows 2008 and higher servers, so Windows 2008 or Windows 2008 R2. All right, so now that I've gone through and created this DHCP server, I now need to create a scope. So I'm going to go through and right-click and create a scope. And I'm going to call this DHCP scope for IPv6. What is my network address block that I'm going to use? FDA8 06C3 CE53 A890 : Got to make sure you put a : that basically says that I'm going to start using from there on out to issue everything beyond that. Preference, if you have multiple scopes, you might want to identify which scope goes first. In most cases, you'll just set it as 0, which is the default scope. Normally in IPv4, you identify what scope you want. You basically say, I want to give you an address from 1 to 100. In IPv6, it does it the other way around. It basically says, what's your exclusion? So there's never, because I did in the previous line, : it's going to basically grab everything, those last 4 blocks, and it's going to give you an IP address across that entire friggin' block. There's going to be 72 million workstation addresses. One of 72 million addresses is going to be blocked from that. If you want to go through and narrow it down a little bit, I might go through and say, I want it to be, 000, 000, 000, 000. And I can go through and block it and narrow it down so that way I can effectively subnet it down a little bit more. Or at a minimum, I'm going to want to say I have servers from 1 to FFFF. And so in that case there, I'm going to reserve effectively that lower end block for my servers. Because I wouldn't want a workstation to come up with the same IP address. Even though I have a 1 in 72 million chance that it's going to happen, I'm going to go through and specifically exclude it. But that's an exclusion range.
Did you just exclude everything?
No, I actually excluded just the bottom because everything up here is actually going to go through and be addressable. So I only excluded the bottom range, that smaller range.
Wait, start and end. Excluded goes from 1 to FFFF.
1 to FFFF.
Oh, right.
But
the first 3 blocks.
The first 3 blocks have not been excluded. Yeah, so those are all still wide open. Lease time, 8 days or whatever, and I can 8 the scope. So there you go. I create a scope. I'm going to toggle over to my my Windows 7 workstation here, and on this Windows 7 workstation right now, I have an IPv4 address, but I don't have an IPv6 address at all. I go through and disable, re-enable. I should go out and tickle my DHCP server. Eventually it does come out. Usually takes a few seconds, and what it's doing is it's going out and has to broadcast to be able to identify that there's an address out there. Well, at some point it'll come up with the address. But just like DHCP, it'll just boom, get an IP address. We'll go back to that in a second here. So That's DHCP. You go through and create a server, you create a range of exclusion, make sure to put the colon at the end of the prefix, it'll go through and issue address. Troubleshooting DHCP. So one of the things that you'll find after you've gone through and statically addressed an IP address on a system is that you try to ping, and you'll get this error, transmit failed, general failure. And what that typically means is that you haven't set up your stateless mode router. And here's an interesting thing, is if you haven't statically defined a gateway, or stateless mode is not set where it knows how to route, is that even though it can communicate to server within a subnet, is that if it doesn't know what the gateway is, it actually will come back with a transmit failure. And this is typically why you'll get an error on Exchange in general, because what will happen is that if you try to ping through IPv6 today on an Exchange server and you didn't set it, statically set it, dynamically set it, you don't have a gateway set up, you don't have stateless set up, is that is usually the error that you get. And that's the reason why most people will tell you just turn off IPv6, because if you turn it off, then you no longer get the stateless error. But two things that you could do. A, give it a gateway address if it's a server. You probably know what the gateway is. Or in stateless mode, you have to go to your router, and in your router, you just go through and create a configure, other config equals true. And what that will do on your router will basically say that this router now becomes a portal out to the internet, an outbound out to the subnet. And so what will happen is that your device will come up, go into stateless mode, communicate with the router, identify that this router is a outbound port, and now what will happen is that you will now have a route, and now when you ping, you'll be able to ping devices yourself. And you can go through and simply do a net shell interface IPv6, and you can add a route. So I can either send this command out to a system, which sets a gateway route, which is good because it sets a route. The bad part is this route is going to be defined in that workstation. Person goes to Starbucks. That's no longer going to be the Starbucks route. They're not going to be able to communicate IPv6 out of Starbucks. Not that Starbucks is going to give you an IPv6 address anyways today, but no use complicating things down the line. What that ends up showing on your system is that if I ping 80 DC1, by default, it's going to communicate over IPv6. If I wanted to communicate and ping through IPv4, I just do a -4. And that will communicate through IPv4. So as long as you set up your gateways, your routes, everything, you should be able to ping back and forth. If not, it's typically a stateless issue, and you make a configuration. Give it a gateway, or set your router properly. Here's that auto configuration thing. The stateless or stateful function is that the stateless is it goes out, sets up an IP address, looks at a router advertisement, it's looking for that other config, and if it identifies what it is, it then knows that's my route out to the internet. And so it's just an inner routing configuration on your router. This is something that from a internet, your infrastructure piece, your Cisco routers or whatever, configure that to be able to set it up as an IPv6 route. Duplicate address detection. So this thing's going to go out and grab one of 72 million addresses or one of 340 undecillion addresses. How does it not make the mistake of setting up an address? There's this thing called DAD, duplicate address detection. Is when a workstation comes up and it dynamically grabs an address, is that it then goes out to the nearest neighbor, what they call a solicitation node, and it says, hey, does this IP address that I'm trying to grab exist out there? This goes out and says, nah, I don't see it. Then this thing grabs the address. Now, this is as good as your neighbor is. If your neighbor is clueless, and it goes out to the neighbor, and your neighbor says, nah, but it actually is used, you're going to get an error. But again, if you have a 1 in 72 million chance of getting it wrong without asking your neighbor, and hopefully your neighbor may actually have a clue, more than likely you're going to get a better than 1 out of 72 million chance of coming up with an error and a duplicate address. So it exists, but it's just know that it does check, and if it checks and this neighbor has half a clue, more than likely you're going to not have an address detection error. But if you use DHCP, if you statically address, you should never have that error, right? That's why, again, DHCP static addressing will address it. All right, routing IPv6 in the v4 world. You set all of your external edge servers in IPv6, just like you do IPv4 address. You statically address them, so that way your www server, your VPN connections, everything is all statically addressed. Your internal workstations are all DHCP enabled, so that way they get an IPv4 and an IPv6 address. Your user takes a laptop, goes to Starbucks, turns it on. They have both an IPv4 and IPv6 address, DHCP enabled. Starbucks is only going to give them an IPv4 address. They don't support Starbucks, McDonald's, Hyatt hotels. They only give you IPv4 addresses. How do you then communicate with IPv6? And the way you do it is by default the way that Windows 7 and Windows 2008 communicate is they first try to communicate natively over IPv6. So if it had a statically addressed IPv6, it'll communicate IPv6. If Starbucks doesn't give an IPv6, it skips all of this and goes straight to just IPv4. Gives an IPv4 address, thereafter it's IPv4. If you have a statically addressed IPv6 address, then to be able to shove that into an IPv4, there's several different protocols. Teredo, ISOTAP, 6-to-4, and IP-HTTPS. Two of these work and two of these don't. And I'll talk about where these things kind of fit in. So your servers are back here, IPv6, IPv4. Your workstation's over here, IPv6, IPv4. But the internet, the Starbucks is IPv4 only. And the number one standard that, and again, the theorists use in IPv6, IPv4 translation is what they call 6-to-4. Meaning that it takes an IPv6 address, squunches it down into an IPv4 address. So it takes your IPv6 address, if that's your IPv4 address. It goes through and converts the decimal to hex. So now 207.213.246.1 becomes 202, 2002, CDDF, F601, CFD5, F601, and it just goes through and relays the information. Very simple concept, takes 6-to-4. The problem with it is 6-to-4 does not route through network address translation, source or destination. And that's the problem, is that every place that you go, hotel, Starbucks, they give you a NAT address. They don't give you a publicly routable address, and nor do you use typically public route address on here. Everybody uses NAT, so the number one standard that the theorists use will never work in the real world. I've never gotten 6-to-4 to work unless I'm actually sitting there on both ends having full IPv4 addressing. So great concept, never works. Second standard that they use is Teredo. The advantage that Teredo uses is that it will work within IPv4 NAT transversals, but it uses UDP. What it takes is it takes the IPv6 packet, shoves it into UDP instead of TCP IP, and sends it through UDP. Great concept. Also, works fine in NAT though, but the problem is typically since they're using UDP, most places block UDP as a method of transport. So this also doesn't work. So the second method that the theorists say you should use for routing also doesn't work in the real world. I've never gotten Teredo to work outside of a lab. I mean, it's a great concept, but it doesn't work. The last two standards, ISOTAP and IP-HTTP. So ISOTAP creates this routing, and effectively it's like a VPN. It takes your IPv6 address, it establishes this ISOTAP VPN over the IPv4 network, and then encapsulates it on the other end. And so effectively you need an ISOTAP agent on your client, and then you need an ISOTAP router on your remote server area, on your server end. By default, Windows 7 supports ISOTAP. You don't have to load any drivers, you don't have to load any agents. The minute you turn on Windows 7 will communicate first through IPv6 natively. If it fails at IPv6 natively, it tries 6-to-4. If it fails at 6-to-4, it does Teredo. If it fails at Teredo, it does ISOTAP. And what it does is it fires up effectively this ISOTAP VPN-ish thing. It's not called a VPN, but I call it a VPN because the concept there is it fires up the ISOTAP protocol. It creates this tunnel through the IPv4 network. It hits an ISOTAP server over here that unencapsulates the traffic and sends it back to your IPv6 network natively. This works great if you're a Windows-only environment for the most part, because Windows 7 supports ISOTAP, and if you're using something like Microsoft Threat Management Gateway, TMG, ISA Server, those also support ISOTAP. You can even go through and set up a Windows 2008 or Windows 2008 router using RRAS, and I can do an RRAS connection through ISOTAP. So it works extremely well, but for the most part, it works almost exclusive in a native Windows-based environment. We typically find that a lot of these Cisco firewalls don't support ISOTAP. We also find Macs don't support ISOTAP, and so if you have mixed environments, you might find that the Mac won't communicate through a Cisco firewall to get back into the network. But if you support ISOTAP, this is a great method of going through and communicating. We typically find in a Windows-only environment, 80 to 90% of the time, you're communicating through ISOTAP, which is good. If you have a Mac, if you have other hardware over here, you may not communicate through ISOTAP. The fourth method that seems to be fairly functional is this IP-HTTPS. Good part about it is it works just like RPC HTTPS. So if any of you have ever used Outlook, Outlook uses RPC, remote procedure calls, to communicate with Exchange. RPC doesn't communicate over the internet, never has. And so what Microsoft did 10 years ago is they took your RPC communications, squished it into an HTTPS, port 443, and shoved it over HTTPS. So every firewall that allows you to surf the internet will allow this Outlook email to communicate through IPv4, through HTTPS back out to your server. Microsoft did the exact same thing with IPv6. They take the IPv6 packet, shove it into an IPv4 port 443 HTTPS packet, and sends the information across. So that means that every firewall, Cisco and Brocade and Microsoft, TMG, and what have you, allows you to have that information go through, and it uses an HTTPS packet. So we typically find that for the 80%, 90% of the time that I can do ISOTAP, the other 10, 15% of the time you use, it goes through IP HTTPS. The bad part about it is the Microsoft standard, and I tell you, you get slammed hard when you actually now call the purists that have never ever managed a network in their life, but have great opinions about things, to use a Microsoft standard. But hey, for those of you in the Microsoft world, it works extremely well. So this is the way that communications. By default, every Windows 7, every Windows Server 2008 R2, this is the order that it communicates with. It first tries to communicate through IPv6, does 6 to 4, does ISOTAP, does Teredo, does HTTPS, and then eventually at IPv4. And again, that's the reason that in most of your networks is that if you're having problems with communications, if you disable IPv6, all 5 of these basically get disabled and you go straight to IPv4. Okay. Tunnel brokers. I think I'm going to do 2 slides and I'll take a break here. There's these people out there called tunnel brokers. If you have your choice of doing 2 things in the way of setting up IPv6, you can set it up yourself and get all the IPv6 working. Or if you don't even want to screw around with IPv6, you can go to one of these tunnel brokers, and if you go to Wikipedia, it basically lists about the dozen tunnel brokers that exist out there. Here in the United States, the biggest one is Hurricane Electric, tunnelbroker.net. And what they will do, and these guys are persistent, is if you post anything on IPv6, these guys will email you until your day ends. And they're like, all you have to do to make IPv6 simple is download our software. And what you do is you basically download this VPN client onto your laptop. You download this VPN client onto your Exchange server and onto your SharePoint server and all the stuff on the back end. And what happens is your Exchange servers, your SharePoint servers, and all your Windows clients, XP, Macs, whatever, communicate through the tunnel broker, and all the IP traffic goes through the tunnel broker. It's a great concept because now you don't have to worry about setting up IPv6 on your workstations or server. But then you kind of sit there and go, wait a second, this tunnel broker now has all of my traffic going through them. What kind of security is there? What performance am I doing? Long term, does it make sense? It's a dumb idea. But these guys are persistent because they are facilitators. And if you download their software, they will set up this traffic. And I've seen small businesses use this. I had a small business that went through and they downloaded the software on their Windows XP workstation and on their Mac. And they downloaded it on their Exchange server. And their Exchange server now communicates through this tunnel broker. Screwiest security in the world that this Exchange server is communicating with this tunnel broker that you have no service level agreement, nothing. But they're able to communicate through IPv6, and that's fine. But anyways, know that tunnel brokers exist out there. It's just a VPN method. I'm going to take a break, but after the break, I'm going to talk about direct access. And as I mentioned, I queued it up, is that direct access is the first real IPv6 application that exists out there. It's one of those things, if you set up IPv6 and you're running it for the next year or 2 and nothing's really moving IPv6, this is one of those things that you guys can set up and play with. It's pretty slick. Is that you can have a Windows 7 workstation running here on your network, and you can then move to the outside of the internet, go plug into Starbucks, and the minute that you plug in and you get an IP address at Starbucks or whatever, is that your F drive, your G drive, your file shares automatically continue to work. And you can see the drive shares, you can see the network. It creates an automatic 128-bit encrypted tunnel back and forth. I'm going to walk you through the configuration of it because there are a handful of tricks to make it work. As I mentioned, there is on the very first and last slide of my deck a URL that gives you this 50-page white paper I wrote on how to set up direct access. I also made available my demo guide. Thing that I always hate, I go to work seminars, the person does a great demo. Of course the guy's going to do a good demo. He's been practicing it a million times. I'm actually going to give you the script of how to configure the system, and every step-by-step line that I'm going to go through today is actually gone through here in an 8-page guide. So that way you can actually go through and set this up and do exactly what I'm going to do here today. So that way this is not smoke and mirrors. You can actually walk through the process I have. I give that to you available. Let's take a 10-minute break. The clock there says 10:08, so 10:18. Refreshments on that side there. Restrooms are out this door here, and we'll pick up in 10 minutes.